All right, guys, so this is the Algebra 2 1.1.1 lesson. So we're going to do things a little bit differently. The very first part here would traditionally be a kind of in-class group activity, because the first section is really just about kind of team building. So we're going to kind of skip that portion, and we're just going to go straight towards the first thing that we can kind of do on a kind of in-person setting. So we have four functions here, f, g, h, and k. And we're trying to figure out what order can we put those functions in, so that if we make this kind of function chain here, where our initial input is 6, and then its output goes into this function, and its output goes into this function, its output goes into this function, and we get our final output here. We want that final output to be 11. And once we've got that, part B is going to be, we want a final output of 131,065, and our initial input is going to be 64. So go ahead and pause the video, try and figure out what order that would work, and then resume it, and I will kind of go through my thought process there. Okay, so hopefully you are back at this point. Change over to this view here. So this is what you typically would do in an in-class setting. So I have my 4 pieces of paper here, right? So we have our F, G, H, and K. So I'm going to kind of walk through some thought processes that I might have when I'm trying to actually kind of do this. So I know that my initial input is 6. If I plug in a 6 into my F function, I'm going to take the square root of 6 right off the bat. That is not pretty. I probably want to avoid doing that at all costs, right? The only things that I want to put in here are going to be positive perfect squares. So like 1, 4, 9, 16, 25. If those things kind of pop up, maybe I want to take a look at this then, right? Okay, and then G, I can really plug in anything here. That's not too bad for me, but I do want to note that this will make everything negative. My square will make whatever's here positive, and then a positive being made a negative will always stay negative. Right? H. So H, I kind of can put anything here. It definitely needs to be a nice pretty number. If it's going to be a negative, then I'm going to be getting fractions here, which I definitely want to avoid having, and it's probably not going to be it. So I'm kind of looking for positive numbers, ideally smaller numbers, but I could use ones that are larger. I mean, I probably wouldn't be putting in like 20 here, or else I'm going to be having some ungodly numbers, right? And then over here at K, I definitely want to be having some kind of even number to plug in here. So I don't want to be plugging in odds into K. So I've kind of eliminated some of these right off the bat. So it could be G, H, or K, because it is even. So I could check all of these. I kind of want to check H last, because that 6 is going to make it larger. So let's try G and K, right? It still could be H, but we're going to try G and K first. So if I take a look at G, right? If I plug in that 6 in here, I get 6 minus 2 is going to be 4. 4 to the second power is going to be 16, and then it's going to become negative. So I have a negative 16 as my output here. So what does that give me as far as options? Well, 16 is great. 16 is a perfect square, so I may say, hey, let's go straight to F. Awesome. But the problem is I have that negative now, right? If I put that negative inside of this radical, it makes my numbers not real, so I can't really do that. So I kind of want to avoid using F. So let's not try F. Well, H, same problem. I'm going to have a negative. I definitely don't want to be doing a negative here, so I'm going to kind of disregard H for a time being and say, hey, let's try K and see if K is going to work for us, right? So if I plug in a negative 16 here, a negative 16 divided by 2 is going to be a negative 8. Then this extra negative is going to make it positive. So I have a positive 8 minus 1 is going to give me an output of 7. Okay, great. So that works. It's a pretty nice number. Let's take a look here at F and H, though, right? If I plug in 7 here, I'm going to get out of 7, which is not pretty at all, so I'm going to avoid that. And then if I do 7 here, I'm going to get a pretty large number. So if I go, well, 2 to the 7th power, I get 128, right? Not too bad, but it's still fairly large. And then I want to subtract 7 from that, and I'm going to get 121, right? So 121, my only option left is, well, I'd have to put it into F. Well, does F work, right? 121 in F, well, 121 is a perfect square. It's probably not one of your most common ones, but it is 11 squared. So if I put rad of 121, I'm going to get an output of E11, and lo and behold, hey, that's what we're actually looking for. So our correct order, which we just found, was the order of G into K into H into F. So that was the kind of order which we found would actually work for that particular function, the very first one, right? So let's take a look at the second one. Now our second one was saying, hey, we want a final output of 131,065, and we want our initial input to be 64. So let's take a look at our current options here, right? So 64, it's positive. That's nice. It's a little bit large. We kind of probably want to make it smaller as soon as possible if we can. But 64 has another very special property. 64 is a perfect square. And those are pretty rare. There's not a whole lot of those. So once we have one, we probably want to go straight to F, right? I have a very perfect square. Let's plug it into F and see where we can go from there. So if I use F as my A initial, right? So plug in my 64, and I'm going to get out 8 as my output there. So rad of 64 is going to be 8, because it's not the positive or negative, it's just the positive option, so I get 8. So now, well, where can I put 8? Well, it can go into any of these, right? This would make it negative, this would work fine because it's even, and this one here, I can do that, but again, I'm going to get a pretty large number there, so I kind of want to avoid it if I can, but it'll work. So let's try these two first here, right? So if I were to go into G, right, plugging 8 in, I'd get 8 minus 2 is 6. 6 to the second power is 36, and then I'm going to get negative. So this would give me negative 36, which works, right? If I plug it in over here, right, I would get, I'm at 8, and then half of 8 is 4, negative 4 minus 1 is going to be negative 5, right? So then I have a negative 5. And so either of those are going to kind of work. So I could kind of do some guess and check, because neither one of those seems better or worse than me. So if I do like this negative 5 in over here, I'm going to get negative 5 minus 2 is going to be a negative 7. And negative 7 squared is going to be 49. So then I get negative 49. Now there's an issue, right? Because now I would have to plug that negative 49 into this H, because it's the only one left. Now I have a negative there, right? So I kind of can't go that negative 5 route. So let's kind of back up. So I know K can't be second, and I know H can't be second, or hopefully isn't second. So let's try G, right? So for G, if I get out 8, 8 minus 2 is 6, 6 squared is 36, I get negative 36, right? So again, I don't want to be doing that negative 36 into H, because that would give me some ugly fractions. So let's try that negative 36 into K. What's nice here is that negative on that 36 is going to become positive because of this negative thing right here, right? So I do 36, and I divide that by 2, and I get negative 18. Negative 36 divided by 2 is negative 18. Then the negative makes it positive. So I have a positive 18. Minus 1 is going to be a 17. So 17 is kind of an ugly number, not one that I really want to plug in into H. But let's think about what we need as our final. Our final answer needs to be 131,000-ish. So plugging that into here, I said 17, right? Yeah, so if I do 2 to the 17th power, right, I get 131,072 minus the 7, and there's our 131,065. So none of the really kind of math here is super hardcore, challenging stuff. The main focus is on the problem-solving techniques and kind of thinking about what works where and kind of what works best, and kind of going through those kind of guess and check motions here. So I'm going to go ahead and change back over to this view. We're going to take a look at the notes real quick, and then we're going to be done. So for these notes, again, I'm going to kind of go through them. They are in your books, so copy down what you need. Always for notes, just take down the parts that you don't already know off the top of your head. So feel free to take notes as you want. Your notes are for you, they're not for me, so take whatever you want, not whatever I tell you to. So These kind of go over functions and what a function is, right? You've been using the term function for quite a while, so you should kind of know what a function is. You're going to see it a few different ways. Here's an equation, here's a table, here's a graph. There's different ways of kind of seeing those. We have what are called dependent and independent variables. The independent is the one which is going to change. The dependent is one that changes depending on what the other one does. So your x is typically your independent, your y is typically your dependent, because you plug in the x, so that's independent, it's whatever you tell it is, but the y changes based off of what x you plug in. That's the way to kind of renumber those. Function machines, we're typically not always going to draw them like the nice little pretty machines you just saw on my papers. Here's a nice, more simplified version of one of those. You're kind of going to see that stuff kind of go away. At this point, we kind of assume you're pretty confident and comfortable with working with functions, that we don't need to draw cute little machines for you, but it's kind of how it works. Domain and range, again, these are terms you've heard a ton. Domain is all your possible inputs, whereas your range is all your possible outputs. So again, your domain is your possible x's, range is your possible y's. And you can see that a few different ways, be it on a graph or a table, things like that. So for our closure, what I want you to do is just kind of pause and just kind of answer to yourself, what different strategies did you use to kind of solve that problem today? So kind of think about, hey, I did this, I thought about that. It's kind of doing that kind of metacognition stuff where you're trying to kind of think about how you were thinking to make you better at thinking, right? All right, and then finally, our homework, and you can just make sure you label this 1.1.1 or 1-1-1, however you want to do it. We're going to be doing problems 4 through 9. It'll typically be everything from the homework, but not always. Like today, we're not doing problem 3. 3 is just kind of, hey, how to make a notebook the way the book likes it. We do ours a little bit differently in this class. So there's your homework, and I'll talk to you guys next time.